Critical Thinking Rule 10. Statistics need a critical eye. In order to assess the meaning or importance of this claim, we need to know the general graduation rate of students and how it compares to athletes. Another thing that'd be good to know is how this current graduation rate of athletes compares to that of previous years. Otherwise, we cannot assess the unspoken implication that the current graduation rate of athletes is better than before. Another factor to consider is that sometimes overly precise numbers can be misleading or problematic. Here's an example. Every year, this campus fails to recycle 412,067 paper and plastic cups. If you got a number like this, you should be a bit suspicious immediately. First, how is this precise number arrived at? Chances are it'd be impractical to count every individual paper or plastic cup that had been placed in a trash can and not recycled on a campus. So presumably this number is going to be an estimate arrived at through some fashion. And whatever estimate it's going to be, it's not going to be precise to the last digit or unit. So you need to kind of question the methodology for how this number was created. Secondly, this claim is that every year the campus fails to recycle the exact same number of cups. And this is an implausible claim on the surface of it. So sometimes we don't even need to know exactly how the number was arrived at to have a suspicion that the number may be inaccurate or misleading. Another factor is that polls can ask loaded questions. A loaded question is a question that contains words or phrases that are intended to trigger a specific answer. So the cartoon on the right says, "What should we do with people who rely on government handouts but are too lazy to work?" That would be a very obviously blatant loaded question, but polls and surveys can subtly bias the results through other types of loading. And you can see this, for example, in political polls that are created by polling groups that are affiliated either with the Democrats or the Republicans or some other ideology. Now, the loaded question of polls or surveys is actually just one particular type of measurement problem. It's the type that occurs when you're trying to collect data from humans by just asking them what they think or believe or whatever. But there's many types of measurement problems that could also turn up if you're trying to gather data. So it really can depend on things like where you're gathering the data from and things about what equipment you're using to generate the data, get your measurements, and so on. So this is just a general problem with any sorts of data we might have when trying to assess statistical analyses of that data. How did you acquire the data, and was it via a biased method? Another type of problem with data is self-reported data. This is when the members of a sample choose to be a part of the sample, and this can lead to self-selection bias. This generally happens with humans if you're allowing them to participate or not participate in a study or survey. An example of this on the internet is Yelp reviews, because not everyone who goes to a restaurant is going to be included in the sample of ratings that you see on Yelp. People choose whether or not they want to leave a Yelp review and rating, and this can bias results in various ways. On the one hand, people who have a very positive or a very negative experience are more likely to post a review on Yelp. If you have a neutral experience or it didn't make a big impression, you're going to be less emotionally motivated to go to Yelp and post a review. And you might think that the fact that both people with positive and negative experiences at restaurants being more likely to post on Yelp would just balance out the results to make it unbiased, but that's actually unlikely. If you have multiple biases operating on a given data set, even if the biases point in opposite directions in terms of how they're going to bias the results, it's unlikely that they would exactly balance each other out. And in particular, we could speculate that there's something called negativity bias by psychologists. People tend to put more emotional weight on negative experiences than positive for a variety of reasons. But one possible explanation for this is that things that are frightening or disgusting or you don't like, those are the sorts of things that could threaten your very life potentially. And so if you have fear, anxiety, or anger about something, your body is going to take that more seriously than if it's positive, because the positive things are nice and you want to have them and get them, but they're not going to threaten your survival If your survival is threatened by something negative, that could end your life as a whole. Whereas a particular positive experience, if you miss out on it, there's still other opportunities after that. So that's a kind of psychological explanation for why negativity bias could bias things like Yelp reviews or other types of reviews. If you have a very positive experience, you're probably more likely to leave a Yelp review than if you had a neutral experience. But if you had a very negative experience, you're probably even more likely than positive because you get really angry, upset, and you're like, I'm going to leave a bad Yelp review. So there's many other types of things that can bias Yelp ratings, including manipulation by the owners of restaurants. But the point is that self-reporting itself can be a source of bias across many types of situations. And finally, there are some general questions to ask when evaluating any kind of statistic. Now, Mark Twain is famous for saying there are lies, damn lies, and statistics. This is actually an exaggeration, right? Because not every statistic is a lie or misleading. And if you try to ignore all statistics, you would have a really bad outcome. I mean, for example, suppose you wanted to figure out what the best way is to commute to work, and you realize, oh, 9 days out of 10, taking the 210 is better than taking surface streets to your job or something like that. Well, if you just are going to ignore all statistics and regard them as lies, you couldn't learn from your environment meaningfully. So the one truth that is at the heart of this claim, though, is that statistics can be misleading in the way they're presented, or they can be misinterpreted just through ignorance or irrationality by the person presenting them. So even if a statistic is true, it's not actually telling you what the person arguing that it's telling you. So we're going to go through 3 questions to ask yourself when evaluating and interpreting statistics. The first is just, what does the statistic actually say? So what's its actual meaning? And there could be a gap between what the numbers are saying and the conclusion the person is trying to bring out of it. So you have to start with just the interpretation. Secondly, are those statistics believable? This can relate to points like overly precise numbers. Oftentimes, even if you yourself haven't read up on a given literature, or you haven't conducted a similar test yourself to gather a number, it can seem implausible on the surface of it. So suppose you don't know the exact population of the United States, but someone told you that the population of the United States of America is 3 million. That's several orders of magnitude off. That's less than the population of the major cities of the United States, such as Los Angeles, the Bay Area, New York, etc. And so you can tell sometimes just on the surface by looking at the numbers, no, that's got to be wrong. So in fact, there's over 300 million people in the United States. It's nowhere near only 3 million. A third question is, do the statistics actually support the conclusion of an argument? Sometimes the statistics are believable and correct, but there's a logical gap between those numbers and the conclusion of an argument. So that's another source of errors in reasoning involving generalizations based on statistics. So we'll give an example of that in the next slide. So for this sample problem, we're assessing the claim and the argument, world population is currently growing at a rate of 1.13% per year. Therefore, world population will double in about 64 years. Now, this argument is relying upon something called the rule of 72, which is often used by investors when they're trying to figure out how long it will take an investment to double if it's growing at a set rate per year. So this rule of thumb is to divide the number 72 by the growth rate of something to estimate its doubling time. And if you use the rule of 72, this argument does seem to check out. If you divide 72 by 1.13%, then you will get 64 years as the doubling time of the world's population. However, there is a problem with this argument. It commits a really basic logical error. Can you identify what that is? This argument assumes a constant rate of growth of the world population, and that is an unreasonable assumption. If you look at the growth of the population of humans over previous years, decades, centuries, it's always changing. So really, in order to estimate the future population of the world, you don't need to only know the current growth rate. You need to predict how that growth rate is going to change in the future years. And that's one of the reasons why estimating future growth or the reverse of world population can be a tricky business. Next up is Rule 11, reckon with counterexamples.